Hey guys, I'm Alex. Welcome to the long-awaited MSA Phase 1. Here, Evelyn, Raymond, and I will give you an overview of the database and API using the .NET framework. As you may know, data is the new oil. Hence, database is crucial because it is where we create, store, and update the data. There are many different types of databases, such as relational, non-relational, key value, and your file system, etc. For the simplicity of this tutorial, we won't go over the exact differences between each one, but we'll be using relational database in our tutorial. I would also like to make a note of SQL, and it is a language to perform tasks such as create, update, and delete data in a relational database. Although you may not see us making any SQL query in the tutorial, but internally, this is how the data is queried. For example, we'll be using the Entity Framework core for our application. It is a library that translates .NET objects, which is your code, into models, which are the way of how the data is structured in a table. When we wish to perform an action on the database, we do not need to write any SQL code because Entity Framework Core directly translates our C# code to SQL under the hood. Let's put the theories aside. Next up, Evelyn and Raymond will bring along exciting video to demonstrate how to create a database and an API. I wish you guys enjoy our video. Thank you.
Before we can start coding, we need to first make our empty Azure database. This is so we can push our model onto our database using migration. Go to portal.azure.com and log in with your credentials. And you should be presented with this homepage. Click on Create a Resource, find SQL Database, and you should be presented with this page. Make sure that the subscription is set to Azure for Students. Create a new resource group and give it a name. This name can be anything, but keep it relevant to the project. Give the database a name and click Create New. Give your server a name. This has to be all lowercase and create an admin account for this database. Make sure that this password isn't used anywhere else because this will be visible in our code and when you submit. Select a location as Australia East. This doesn't have to be strictly Australia East, it can be anywhere, but I just chose it because it is the closest one to New Zealand. Click OK. Go to Configure Databases. It defaults to general purpose, which is, as you can see, cost me $641. It's way overkill and way too expensive, and it will eat into your free credits. So we're going to look for the basic tier, which costs $8.30 a month. Click Apply, and you should end up with something similar to this. Click Review and Create, and once you're happy with the settings, you can click Create. Once your deployment is complete, you should be able to click Go to Resource. If this is grayed out for you, go to School Sims, and you should see two services here, one server and one database. Click the database, and you should see this control panel here. Go to Set Server Firewall, and make sure Allow Azure Services is set to Yes. Create a new rule called Everything, and give the starting IP as 0.0.0.0. Give the end IP as 255.255.255.255. What this is doing is giving an IP address across this range access to our server. Click Save. Click OK and go back to the control panel. Once you're back at the control panel, go to the left hand side and go to connection string. Copy down this connection string somewhere because we'll need this later when we deploy our migration to this database. Open up Visual Studio 2019 and click Create New Project. Search for ASP.NET Core Web Application and click Next. Give your project a name and click Create. Make sure API is selected and ASP.NET Core 3.1 is selected. Click Create. You now have a base project that we'll be working with. Once you create the new project, delete weatherforecast.cs and weather forecast controller. These come default with the project and we don't need them. We now need to install our NuGet packages, so go to Tools, NuGet Package Manager, and manage NuGet packages for solution. Click Browse and search for Entity Framework Core. Select it and install it onto the project. Do the same for SQL Server. And for tools. Now that we install our NuGet packages, we are ready to start coding. Once you install the packages, create a new folder called Models. In this folder, create a new item called Student. Copy the model over from GitHub and you should see two errors pop up. Hover over them, show potential fixes, and click Using. Do this for the second one as well, and your error should be resolved. Here our model is quite simple, however we will update this later on in the tutorial to be a more complex one. Before we can migrate, we need a context for our student's model. The context acts as a bridge between our program and the database. For more information, visit the links in our GitHub. Create a new folder, select Add, new folder called Data. In this folder, create a new item called Student Context. Copy over the code from GitHub and fix all the issues that pop up. Now that we have a context, we need to add our connection string. Go to App Settings and copy the snippet from GitHub. Replace the connection string with the one that you copied earlier in Azure databases. Make sure you replace your password in the string with the Azure database password from earlier. Once you've added your connection string, in the Package Manager console, type in add-migration initial create. This will create our migration code. This code is auto-generated and tells the database what it needs to update. We haven't updated the remote database yet. To do this, we need to type update-database in the package manager console. Doing this will update our remote database with the current model. When the command finishes, the database should be updated with our latest model. We can check the changes if we go to Azure Database. Go to Query Editor and log in with your database details. Go to Tables, and you see two tables here. One was created from our migration, and the second is our database. You can see our model has been updated, and now it's time to create our API controller. So go back to our project. Before we start, we first need to add some lines to startup.cs. It will be under Configure Services. Copy and paste the snippet from GitHub. These two lines are letting our program know that we want to use this connection string that's specified in app settings. Also fix the errors that show up. These are just import errors, so we can just right click and click using. Now that the errors are resolved, we can start creating our API controller. Go to Controller, Add New Scaffold item, and make sure API Controller with Actions and Entity Framework is selected. Select your student model, and make sure your student context is selected. Give your student controller a name, and click Add. We're using scaffolding to auto-generate some API that we can work with. Once the API is generated, we can run the project. Currently, the only way to access our API is through its endpoint. This happens to be the URL of the website that we specified. In this case, it will be our localhost /API/students. The result should end up as an empty array because we have no data in our database yet. Because it's not too appealing to look at, we're going to add Swagger for our API UI. Before we can add Swagger to our project, we first need to add the NuGet package for it. Go to NuGet Package Manager, and search for swashbuckle.asp netcore. Install this onto the project. And it should be installed. Go back to startup.cs, and under Configure Services, add the following line. And fix the errors that show up. Click the using. Everything should be done for the Configure Services method. Go down to Configure and add the snippet from GitHub. What these lines are doing is telling the program that we want to use Swagger when it starts up. Currently on startup, our program still goes to weather forecast, so we need to change this in launch settings.json. Delete weather forecast, and do that for the second one too. Now that our program is all configured, we can run our project. Once our page is loaded, you can see we're greeted with the Swagger UI. We can see our APIs. Now let's test our get method. Click try it out, click execute. As you can see, we get the same result as before. Let's add some data into our database. Go down to Post API Students, click Try It Out, and modify the first name, last name, and email address. For more information on HTTP requests, please visit the links in our GitHub. Once we're done, click Execute. The return response is 201, which means our request has been successful. Let's add some more data to our database. Change the first name and last name and email address again. You don't have to change the student ID because we specified that this will be the key and it will be auto-generated by the database. Now that we have data in our database, go back to our GET request, click execute, and we should get 3 items. We have successfully added data and have retrieved data from our database. Let's go back to our model. Our current model is quite simple. So go back to our GitHub and copy our new model over. Yeah, so key, we still have this. We are now restricting first name to a max length of 100, and it's a required field to be entered. We added a middle name. Same with last name, it's required. Email address and phone number are not strictly required, and now we've added a timestamp that's added into our database. Save. Go to Package Manager. Add migration. Update model students. Click add. Should build. You'll get a warning. Just in the case where you remove a column, you could lose some data. The migration code will be added into the migrations folder. Run update database. When that's done, our database should be updated with our new model. Your existing data should still remain. If you remove a column, your data may be lost. Go to Azure and go to your database. Go to Query Editor. Here's our old model. If we click refresh, tables, students, we can see our model has been updated. If we go to E of migration history and select top 1000 rows, we can see there's 2 records that's been entered. These are from our migrations from our code.
Hi, so now I'm gonna show you how to deploy our finished .NET Core Web API to Azure. Firstly, go to your Project Solution Explorer and open up your startup.cs file. From here, we will need to configure the application to enable CORS policy so that we can host it on Azure with Swagger UI. In your configure services, we will need to add cores. And then in the configure method, we will add the following lines to configure the cores using when we launch the app. So after we added in the configuration for cores, the 2 methods will be look like this. Under configure services, we will have service.addCores, and under configure method, we will have app.useCores and all the configurations that are needed. Then we'll go to the deployment. In order to deploy our .NET Core application to Azure, we need an Azure account with subscription. If you are a student, you can register student subscription with Microsoft Azure. You can log in by go to portal.azure.com, and from there log in into your Azure account, which is registered with the student subscription. From here we will search for app services. If you have never created any app services, then this site for you will be blank. We will create a new one by clicking the add button here. And from here, we will need to fill out the following fields. The first one is the subscription. Here I chose my Azure for Student one is default here. And the resource group, I will choose MSA 2020. If you don't have one resource group, then just create a new one by clicking here. And after that, we will give the application name MSA Phase 1. Later on, you can access your APIs by calling msa-phase1.azurewebsites.net. For publish, I will choose code and runtime stack. Since our application is using .NET Core 3.1, so I will choose .NET Core 3.1 here. And operating system, I will choose Windows. region, Australia Central. Window plane, you can choose your existing one or create a new one if you don't have one. And for the SKU and size, I choose the smallest one, which is the free F1. And for the monitoring, I just turn it off because I don't need it. You can turn it on and then play around with the application inside. It's really useful, but we don't really need it here, so I'll just choose no. And I'll go to review and create it. Make sure to check all of these fields to be correct and then click create, and it will deploy your empty application to Azure server. It will take a while to make your deployment successful. So after we have configured the web services on Azure, we are now moved to deploy our .NET Core Web API code to Azure. Now going back to Visual Studio and right-click your API project and choose Publish. Because this is my own publishment, so don't worry about that. It will pop up you to create a new one, which is this pops up. And from this, we will choose Azure as our target. Click Next. For specific target, we will choose Azure App Services for Windows. And then click Next. So make sure that you are logged into the correct Azure account here using your email and password. Choose the subscription and correct view. Then I will choose the correct web services that I have just created, which is the MSA phase 1, and then I click Finish. From here, as you can see, the service dependency is not configured yet, so we need to configure them as well. So it is Azure SQL Database, so I'll choose this one. And then I will choose the correct database that I will link my application to, which is the MSA 2020 phase 1, and then click Next. And from here, I will need to input my username and password, which is the username and password that you have created for the database on Azure before, like when you build the application. And then Next. I'll choose both of them and then click Finish. Wait for it to configure. After it's completed, then just close. Here you can see it's already configured successfully. So now we just need to click Publish. You will need to wait for a while for it to be published. After it's successfully published, it will automatically pop up the website here, as you can see, msa-phase1.azurewebsites.net, and it goes to the home page index.html. If it doesn't automatically pop up, you can click the site URL here to access the website. Okay, let's test the GET request online. Let's try it out and execute. And it works. The server responds with the 200 status, which include all the students' instances here. Okay, that's it. We have done with hosting your .NET Core API on Azure, and I hope that you will enjoy the MSA 2020 phase 1. Thank you very much.